My name is Joshua, and I'm an INTP, and first and foremost I would like to say thank you for viewing this video, and hopefully you're enjoying your holiday season. Now, the topic of this video I would like to talk about is introversion and extroversion. Primarily what I would like to discuss are the distinct physiological and neurophysiological factors of introversion and extroversion, but I will first start with Jung's thoughts and description of introversion and extroversion. Truly, what this video will show to be is a substantiation of Jung's thoughts just through an empirical lens, really, or what the data shows thus far, in its cooperation with with roughly Jung's original hypotheses on the nature of introversion and extroversion. So first, what Jung described introversion and extroversion as was one's attention, one's interest, and primarily the flow of one's libido. So the flow of one's energy, not in the Freudian sense of the word libido as in one's sexual energy, but the Jungian sense of the word as in one's psychic energy. So an introvert's psychic energy is one that's directed towards the self, where the extrovert's psychic energy is one directed towards the external environment. Now, certainly there have been many psychologists and researchers who have come post-Jung to give their own thoughts and conceptions of introversion and extroversion, and the most recent recapitulation of this idea, these ideas exist in the Big Five model, but that's not where the physiology sort of is pointed to and direct, or at least where it stemmed from. Primarily, the physiological model of introversion and extroversion was first proposed by a man named Hans Eysenck, and Eysenck's theory of introversion and extroversion has to do with the orientation to stimulus. And it's to say that the reticular activation system in the brain is one that's primarily concerned with waking somebody up, giving them a base amount of energy in order for them to respond to the environment, and regulating how they handle and take in stimuli or stimulus, external stimulus. And so what Eysenck's hypothesized, due to an experiment where they had people who identified as introverts take a drop of lemon juice, and they had people who identified as extroverts, and they had them take a drop of lemon juice, and so they ingested lemon juice, and what researchers found were introverts salivated with greater intensity than extroverts, and so it led to the hypothesis that introverts are more susceptible to external stimuli, to where extroverts are less susceptible to external stimuli. So extroverts go out and seek stimulus in the environment, to where introverts, they retract from stimulus out in the environment because they can be too stimulated. And I think that is something that anyone who's introverted or extroverted can deduce from their lay experience, really. And so it's to go more into this description of Eysenck's and what it's led researchers to understand and know about introversion and extroversion that I really want to talk about. And so introversion and extroversion, it is this divisional dichotomy in the body itself, and it seems that this divisional dichotomy exists in the autonomic nervous system. The autonomic nervous system is the nervous system of the body that's controlled with unconscious regulation of things, such as urination, heartbeat, eyelid blinking, the movement of smooth muscle fibers such as the heart and the kidneys and the stomach and peristalsis, all these different activities that your conscious mind doesn't control, that is in the control and sovereignty of the autonomic nervous system. And it seems that the autonomic nervous system divides itself into various nerve fibers, one comprising two different nervous systems, subsystems within the autonomic nervous system, which would be the parasympathetic and the sympathetic nervous system. Now, every individual, like Jung originally postulated, has the parasympathetic and the sympathetic nervous system, and you'll see why I'm saying why Jung postulates later on in this statement. But every individual has activity going on consistently from both branches of the autonomic nervous system. It just seems that introverts, they tend to have more activity in the parasympathetic nervous system, to where extroverts have more activity in the sympathetic nervous system, which the parasympathetic nervous system and the sympathetic nervous system is active within all individuals. It just seems that if somebody, and I say seem and literally mean seem because this is deduced and being induced, sort of derived from empirical data, but it just seems, according to experiment, that individuals who are introverted tend to have higher activity with the in the parasympathetic nervous system, and the extroverts have higher activity in the sympathetic nervous system. It is just to say that both are active because the parasympathetic nervous system is necessary for certain functions of the body in general, and the sympathetic nervous system is necessary for homeostasis and body regulation levels, period, for introverts and extroverts alike. It just seems that the division has more weight for one one personality than the other, just the general dichotomy between introversion and extroversion. And so there's some interesting factors that rise out of this emphasis on one nervous system, one type of autonomic nervous system regulation over the other, because roughly the division works like this. The parasympathetic nervous system for introverts is one that's concerned with the rest and feed state of being, or the breed and feed state of being, as researchers call it, to where the sympathetic nervous system seems to be more is the one that regulates the fight or flight response. So I'll go with extroverts, the sympathetic nervous system, and the fight or flight response first, because I think that, well, just for parity's sake, because I'm an INTP, so I don't really want to talk about introverts first and seem biased. So just for parity's sake, I will talk about extroverts first, and say this, that the way the extrovert's body, literally the unconscious governings of their body, it regulates them to be able to respond to the environment in such a manner. Because the sympathetic nervous system, it's concerned with attention, it increases heart rate, it increases it's responsible for increasing muscular tension. Extroverts, they're primed to respond to the environment primarily. It's not to say that they don't rest and they don't deliberate, is which we'll see is more indicative of the parasympathetic nervous system. Is just that their main orientation, it seems the evolutionary strategy that extroverts have is to pay attention to the environment, and that's their prime direction orientation, like Jung postulated, which I think is just so amazing. But it's to say that the neurotransmitter, because of the that's most active within their central nervous system, within their central nervous system and the individual, is dopamine, and because of this emphasis of the sympathetic nervous system, is aired with adrenaline. So dopamine and adrenaline seem to be the neurochemicals that have the greatest instigation in the extrovert's behavior. So adrenaline, I think most people have a sort of lay familiarity with it. It really prepares you for survival in a lot of ways, and being able to respond to immediacy in the environment. It's just excitation in immediacy. That's what it seems to be geared towards and what it helps people to do. So extroverts by nature, it's why extroverts can sort of walk into a room in some respects, be surprised by something, but know how to deal. I'm just postulating. This is speculation at this point, but I think this is just why they're able to walk into the room and be surprised by something and able to deal with it and handle it a lot better than I can, because I don't like being an introvert can. I don't like being surprised, but it's not that extroverts like being surprised necessarily, but they're able to handle surprise, and they're able to handle the environment and it being stimulating towards them, and that's, to me, that's rather fascinating and amazing. There's also something to note too, is that dopamine, the reward network, is much stronger in extroverts than it is in introverts. And it's why Jung, he said that extroverts' libido, their energy flows outward. It seems physiologically, primarily this is because dopamine is part of the reward network, and the reward network is concerned with achieving outward results. It's concerned with approximating an individual towards rewards, just literally within the name. And it's also, well, just to say that, and to know that dopamine and norepinephrine, they act in conjunction. So extroverts, they look at things in the environment, and they see it, they want it, they go after it, and they dial in, because norepinephrine and dopamine, they work in conjunction to sort of tunnel vision, laser-like focus the extrovert or the individual towards what they want. And based on the individual getting closer to the goal or further from the goal, they reward the individual either with the brain rewards but the brain rewards the individual with either more dopamine, which is just makes somebody feel elated per se and excited, or it penalizes them and raises their cortisol levels. So the pain-pleasure principle really arises, I think, from this neurococktail interplay. It's just that extroverts, they can be swayed sort of and be moved by the environment because of this relationship to dopamine and the reward network in their brain, which is, I think, why you can punish extroverted children, and they pay attention to it probably more so than an introvert child would. At least I know I don't pay attention. So these external rewards, they seem to pay attention to them better, and they seem to be driven very innately to pay attention to these things and try to get what they want in the environment or what they see in the environment. Their primary goal is to be receptive to their primary orientation is to be receptive to the environment, and then to go get things in the environment, approximate themselves towards things in the environment, distance themselves from things in the environment. It's just their literal makeup is one towards the external world, which is like what Jung said, which is why I think it's so interesting and exciting at the same time. I'm such a nerd. If you can't tell, I'm getting geeked out about these ideas. But that seems just to be how extroverts are. And also something to note, it makes extroverts more risk-taking than introverts, which I think is, it's something that's evident in lay experience, but it's funny to see that there's a potential physiological connection insofar as that the raising of dopamine and norepinephrine levels in the brain gives somebody a singular focus. So a person is not able to scan the peripheries, essentially, well, sort of metaphorically, and take in the risk that may be involved in the situation. And that's also why men seem to be more geared towards risk-taking behavior, because testosterone and dopamine are co-conspirators. When you have one, you have higher levels. When you have higher levels of one, you have higher levels of the other. And so it seems that extroverts, they will go out in the environment, they'll take risk in a certain sense because their brain is saying, don't pay attention to the potential frightening factors going on here, and take risk, take risk, take risk. Orientate yourself more towards this thing. And that's also why people say love is blind, because you're hopped up on dopamine and norepinephrine and all these other and testosterone and serotonin, these different neurochemical cocktails that just make you completely oblivious and non-critical in your evaluations. And that's how the extrovert is leaning. It's so, to me, that's so cool. It's so interesting. So that's extroverts. And also I was just looking at some notes. Also, it seems that the sympathetic nervous system, it's energy spending in orientation. So it's because of how the neural configuration, the networks that extroverts use to make decisions and regulate their body and the environment, that sort of gives them the impetus to be energy spending. But their energy spending, essentially, that's what their makeup is. They spend energy and they receive energy. They receive stimulus from the environment, and they spend energy in response, in respect to the stimulus they receive in the environment. Also seems that extroverts, they use a shorter pathway for making neural pathway for making decisions. It comes into the reticular activating system, and then it passes through 4 other neural networks, which I'm not going to trouble you with all the anatomy, but it starts with the reticular activating system and goes through subsequent 4 other networks. So 5 networks extroverts go through to be able to make decisions and respond to the environment. Whereas we'll see with the introvert, there's a few more than that going on for the introvert. But it's just to say that we love our extroverts because they are susceptible to the environment, and they're responsive towards it, and they're willing to throw themselves into it and to transform it, and it's a wonderful thing. And it's a very necessary evolutionary strategy, and I think that's why we have extroverts. And that is the extrovert's neural disposition. So now on to the introverts, and I mentioned it previously, but the division that seems to be more active in the introverts is the parasympathetic nervous system, which is the breed and feed nervous system, or the rest nervous system. So introverts, we are adverse to stimulus, and both introverts and extroverts have a relationship to dopamine. It just seems that extroverts are less sensitive to dopamine, so they want more of it, and introverts are more sensitive to stimuli and more senses in general, but primarily to dopamine, so they want less of it. They don't want to be excited necessarily as much as the extrovert does. And also within their central nervous system, the neurotransmitter that's most activated is acetylcholine, which has a multitude of functions in terms of regulating the unconscious systems of the body. But primarily what acetylcholine does, in a sense, is to send messages to different regions of the body and the brain. It brings things to the brain, and it helps the brain create more synapses and move things around in it. So introverts, they seem to be more geared towards their memory and learning per se, and it also has a very distinct function in inhibiting excitation. So it's an inhibitory excitatory has an inhibitory excitatory function. So it inhibits excitement. It makes introverts want to be calm, and it's probably why introverts don't like too much stimuli to begin with. And I mentioned this briefly, but it's also concerned with neurosynaptogenesis, and it's acetylcholines present in extroverts and introverts. It's just that these neurotransmitter levels seem to be higher in one than the other. They're ubiquitous human agents per se, but it just seems that if you're an extrovert, you tend to have more of the dopamine and the use of adrenaline and norepinephrine, and if you're an introvert, you have more of the acetylcholine going on in your brain space. And introverts, because they have acetylcholine and the networks of the brain that talk to one another because of acetylcholines use, seem to be concerned with memory and long-term decision making. So I think it's why introverts have the look before we leap sort of orientation towards the world. We're also sorry to stay on that. It's just that it seems that introverts, they take in stimuli, they pause themselves, they work through their memory, then they observe it and analyze it and figure out what they should know about it, then they make a decision. So there's there's more going on in an introvert's mind in response to a stimuli. And that's been demonstrated in multiple experiments through just multiple vantage points. So not even looking at the autonomic nervous system relationship, but just that introverts, they have what psychologists call alert, prolonged attention, and we also, when introverts are given tests and to sort of the test where you have two pictures next to one another, but one picture differs from the other picture with a number of different subtleties. Introverts consistently score higher in picking out the subtleties between the two pictures, is because introverts seem to be orientated to the environment to do primarily one thing, and that is to pay attention. So introverts we pay attention. We do not necessarily want to react or act, but we want to pay attention, learn, store the relevant information, and make decisions with it. Extroverts, they make decisions. Don't misunderstand me in hearing that extroverts don't make decisions, but they don't seem to make decisions through the same process that we make decisions, and they seem to be willing to make decisions in the moment, working through a thing, to where introverts, we don't make decisions in the moment, we don't work through things, not if we can choose not to do it. We want to figure things out beforehand, before ever engaging in them. And this is because of the orientation of the parasympathetic nervous system, which I think is just, and sorry, I'm checking my notes. And because of the orientation of the parasympathetic nervous system, there's just more signals traveling in the brain of the introvert than in the extrovert. We go through seven neural pathways just to respond to a stimuli. It all starts with the reticular activating system, but then it moves through other neural pathways, and to where the extrovert uses three of the five are the same as the introvert, and then the other two different, because the extrovert is more geared towards acting in the external world. The seven that the introvert, just the fact that the introvert has 7 and the extrovert has 5 is just telling me that one is more in their head than the other, per se. And acetylcholine, it is an instigator in that, and there's just always more mental activity in the introvert than the extrovert, per se. And we're geared to have a great deal of mental activity to be directed towards the subject, and to like to be calm so that we can actually think about things and solve problems, which there is a experiment done by a researcher named Russell Geens, and what Russell Geens did, he had several college students solve math problems, and he had them solve math problems in a environment with music and an environment without music. And so if the student was extroverted, they did better in solving the problems in the environment with music. If the student was introverted, they did better in solving the math problems in the environment without music. It just goes to show that it's just demonstrating for most introverts. I'm not saying it's like this for all, but it's just to say that for most introverts, we like low stimulation, and we like to be contemplative to some extent, and it's because of the parasympathetic nervous system. We're not geared to respond towards the environment in the same fight or flight and expedient manner as the extrovert, because we have somewhat, it's not an averse relationship with dopamine, but it's a sensitive relationship with dopamine. We're more sensitive to it, so we don't want as much of it, and we tend to hoard or be covetous with acetylcholine, and we have large amounts of it present within our body and our brain. And acetylcholine's job is just to transmit messages all through the body. We're constantly transmitting and sending signals between the organs and the brain, and it just seems that introverts, we're signal senders. That's what our body and that's what our brain does. It transfers information from one place to another place. It's the transference of information which is going on in the introvert's world, and it's the internal transference of information, towards the extrovert, it's the external stimuli creating the transference of information. They're getting the information from the external world and doing things with that. So where the introvert, like Jung postulated, is getting information, is moving information around in the external world and making decisions about the external world with the internal information, which is what Jung said. And so that, I just think it's so fascinating, and also why I think that appreciate introverts and extroverts, because we are what we are, and they're distinct attitudes, they're distinct modes of being. They've done several studies and where they've tried to determine how much of one's personality is genetic versus environmentally dependent, and particularly with the trait of extroversion, because there's an extroversion bias. And with extroverted behavior primarily is because what the behaviorist movement, I don't dislike behaviorism. I'm just saying that so many people look at extroversion as a behavior, and they look at the behavior of extroversion, and they find that only about 38% of it, 38 to 52% of it can be described in environmental factors. And it's just to say that people have their personalities, and Jung was right in saying that there are completely different orientations to the world, because they're completely different orientations in the person's neurological makeup, the actual tree branching structures that stem from your brain to your spine. The divisions within them, they're more emphasized and nuanced, given if you're an introvert or an extrovert, which I think is such a beautiful and profound thing. And credit Jung for being the insightful and amazing thinker that he was. I know no man who is able to understand the human being as much as Carl Jung was, and to predict and postulate so many things that history is showing true. So that's my video on introversion and extroversion, the physiological and neurophysiological aspects of the two. I will do another video on introversion and extroversion, but primarily the Jungian typological thought on the two dispositions. But this had quite a bit of Jung's ideas in it, but the research was just utterly fascinating and brilliant. So I had to do a separate video on this alone, and we'll save Jung's ideas for another video. So thank you for watching, and have a happy New Year's. Or enjoy your holidays. It's not quite New Year's yet, but happy New Year's either way.